The universe is full of wonders, and sometimes, those wonders can be terrifying. Consider the scenario presented in The Last of Us, a fungal pandemic, not a virus, not bacteria, but a fungus. This idea grips our imagination, doesn't it? It taps into a primal fear, the fear of something ancient, something elemental turning against us. We explore the cosmos for life, yet life on our own planet constantly finds new ways to challenge our dominance. This particular fiction feels disturbingly close to a potential, albeit exaggerated, reality. Why does this specific kind of apocalypse resonate so deeply? Perhaps it is the insidious nature of fungi. They are decomposers, recyclers of life. But what if they decided to recycle us before our time? The Last of Us presents this what if with chilling precision. The story doesn't just throw monsters at you, it presents a biological horror, a perversion of natural processes. It's the thought of losing control, not just of society, but of our very minds and bodies that truly unsettles the human psyche. So let us embark on a journey into the science, both real and speculative, behind this fungal nightmare. The villain of our story is not a creature from deep space. It's a fungus, a mutated strain of. In the real world, various species of Cordyceps are known as insect pathogens. They are highly specialized, often targeting a single species of ant or moth. They are nature's microscopic puppeteers. The creators of The Last of Us imagined a terrifying evolutionary leap. What if one of these fungi evolved to see humans as its next preferred host? This is the core of the terror. This fictional Cordyceps didn't just learn to tolerate humans, it learned to thrive, to control. The mutation, as the story suggests, might have been spurred by environmental changes, perhaps a warming planet making new niches available. The fungus adapted, overcoming the thermal barrier of the human body, a defense that keeps most fungi at bay. It rewired its genetic code to recognize human neurochemistry. The infection, in this grim narrative, begins insidiously. Through airborne spores, a common route for fungal infections, or through the bite of an infected individual. To understand the terror of the fictional Cordyceps, we must look to its real-world inspiration. Nature is often stranger than fiction. The complex, famously known as the zombie ant fungus, is a prime example. These fungi are masters of manipulation. They don't just kill their insect hosts, they control them in a remarkably precise manner. An unsuspecting ant forages and a microscopic Cordyceps spore lands on its body. This is where the ant's doom begins, a slow, methodical takeover by an alien intelligence. Once the spore adheres, it germinates, penetrating the ant's tough exoskeleton. Inside, the fungus begins to grow, spreading its network of hyphae, which are like tiny threads throughout the ant's body. It consumes the ant's non-vital tissues first, keeping its host alive. But the fungus is not just feeding, it's producing chemicals. These chemicals interact with the ant's nervous system, altering its behavior. The ant, once a social creature following the colony's rules, becomes an outcast, driven by an unseen force to abandon its nest and normal routines. How could a fungus, so finely tuned to infect insects, make the colossal leap to humans? This is where the science fiction of The Last of Us truly shines, by grounding its horror in plausible, if extreme, biological concepts. We know that diseases can jump species. These are called zoonotic diseases. Influenza viruses jump from birds and pigs to humans. HIV made the leap from primates. The natural world is a dynamic system, and pathogens are constantly probing for new hosts, new territories to conquer. For Cordyceps to infect humans, several significant biological barriers would need to be overcome. The most formidable is temperature. The internal temperature of mammals, around 37 degrees Celsius, 98.6 Fahrenheit, is a powerful defense against most fungi. Fungi generally prefer cooler, damp environments, so the fictional Cordyceps must have mutated to tolerate and even thrive in this warmer, human internal climate. Section 5. Humanity's Unfortunate Invitation. Why we are perfect hosts. Once the mutated Cordyceps makes its leap, why are humans such particularly good or rather unfortunate hosts? Our very complexity becomes a vulnerability. Consider our brains. The human brain is the most complex structure known in the universe. It's the seat of our consciousness, our intelligence, our emotions. For a fungus aiming to control behavior, this intricate control panel offers an irresistible target. The fictional Cordyceps doesn't just want to feed, it wants to drive, and our advanced nervous system provides the sophisticated machinery for it to do so effectively. Then there's our social nature. Humans are highly social creatures. We live in dense communities, we travel, we interact closely. These anthropogenic factors, our cities and global networks, become superhighways for a pathogen like the mutated Cordyceps. Section 6. The Animal Kingdom's Immunity, a tale of temperature and biology. A curious aspect of The Last of Us is that the Cordyceps infection seems largely specific to humans. Dogs, horses, birds, they roam the post-apocalyptic landscape seemingly unaffected. Why would this be? The primary shield for most mammals and birds against the vast majority of fungal species is their high body temperature. Most fungi are mesophiles, preferring moderate temperatures, and simply cannot replicate effectively or cause invasive disease at the sustained 37 to 40 degrees Celsius, or 98.6 to 104 degrees Fahrenheit, found in warm-blooded animals. This thermal barrier is a powerful, ancient defense. So, if the fictional Cordyceps mutated to overcome this barrier in humans, why not in all mammals? The story implies a highly specific adaptation. Perhaps the mutation that allowed it to thrive in human hosts also made it too specialized. It might have adapted to the precise temperature range and immune system quirks of Homo sapiens, making it less effective or non-infectious in other animals with slightly different physiologies or core temperatures. Evolution is often a series of trade-offs. Gaining an advantage in one area can mean losing flexibility elsewhere. Section 7. Fungal Foes Among Us, Real-Life Human Mycoses. While the Cordyceps of The Last of Us is a fictional nightmare, fungi are very real pathogens for humans. We encounter them constantly. Most are harmless, but some can cause diseases known as mycoses. Think of common ailments like athlete's foot or ringworm. These are superficial fungal infections, annoying but usually not life-threatening for healthy individuals. Yeast infections caused by Candida species are also common. Our bodies typically keep these fungi in check, coexisting with a universe of microbes both on us and within us. However, some fungi can cause far more serious systemic infections, especially in individuals with weakened immune systems. Diseases like aspergillosis caused by Aspergillus mold, often inhaled, cryptococcosis from Cryptococcus yeast, also often inhaled, or invasive candidiasis can be life-threatening. These fungi can invade the lungs, bloodstream, and even the brain. Treating systemic fungal infections is notoriously difficult. Section 8. The Science of Storytelling. Why The Last of Us Captivates. The enduring power of The Last of Us lies significantly in its clever use of science, or at least scientifically plausible concepts. Grounding the fantastical horror in real-world biology makes the impossible seem terrifyingly possible. The creators didn't just invent a monster, they extrapolated from one of nature's strangest phenomena, the Cordyceps fungus. This foundation in reality lends a chilling credibility to the narrative. It whispers to our subconscious, "This is an exaggeration, yes, but the seeds of it exist in the world around you." This makes the story far more engaging than a purely magical or alien threat. The game and subsequent show meticulously detail the infection's progression, mirroring biological processes. The different stages of infected runners, stalkers, clickers, bloaters, each represent the fungus further consuming and transforming its human host. This isn't just about increasingly grotesque monsters, it's a visible timeline of biological horror. Runners are recently infected, still fast, their humanity barely submerged. Clickers with their hardened fungal plates show the long-term adaptation of the fungus, even developing a form of echolocation. This biological realism draws us deeper into the world and its rules. Section 9. Beyond the Spores. Contemplating our cosmic vulnerability. The chilling narrative of The Last of Us, while fiction, serves as a stark reminder of our actual vulnerabilities here on Earth. In the real world, we are witnessing the rise of drug-resistant fungi such as Candida auris. This dangerous pathogen can cause invasive infections and is difficult to treat, posing a serious threat in healthcare settings. Furthermore, scientists are genuinely concerned that climate change could drive fungi to adapt to warmer temperatures, potentially increasing the number of species capable of infecting mammals, including humans. The universe is always testing life. This underscores the critical importance of scientific research and global preparedness. We need to understand fungal biology better, from their genetics to their mechanisms of infection. We need to invest in the development of new antifungal medications and diagnostic tools. Vigilance is key. The fictional Cordyceps pandemic highlights how quickly a novel pathogen could overwhelm unprepared systems.